All right, so there's this confidence interval question in the notes on the two-sample proportion hypothesis test and confidence interval section in week 7 material. So there's this study that was done comparing children that attended preschool versus ones that did not, and the percentage of those students that required social services later in life. So I've worked this question by hand, using the defining formulas. What I'd like to do right now is show you how to work this question in both Minitab Express and in the TI graphing calculator. Actually working these questions in, statistical programs such as Minitab with a calculator, it's really pretty fast. You just have to basically input the information and it crunches all these values for you. So it says here, in a study done in Michigan, it was determined that 38 out of 62 children who attended preschool needed social services later in life. That percentage is over here, 38 out of 62. That's a sample percentage, p hat. It's about 61%, as you can see. And then it said compared to 49 out of 61 children who did not attend preschool. All right, and that sample percentage, 49 out of 61, is about 80%. So you can see it's like a 19% difference between those that went to preschool and those that didn't, and out of those who needed social services later in life. All right, so they want us to calculate a 99% confidence interval for the difference. So the big question is, we didn't ask every single student that attended preschool, hey, did you need social services later in life? And then the same thing, every single child, here in Michigan that didn't attend preschool, that's why these are sample percentages. So the big question is the population percentages or proportions, the P, the actual P1 and P2, not P hat 1 and P hat 2. What is the difference between P1 and P2? All right, well, this is why we calculate a confidence interval. It's going to estimate it. All right, so here it is worked with all the formulas, calculating the standard deviation, plugging into the confidence interval formulas. Let's show you how to put this in Minitab. It's really not too bad at all. So all the confidence intervals and hypothesis tests are in the Inference menu. So we've been using this a little bit. So here's the 2 for proportions. This is the 1 sample proportion, hypothesis test and confidence interval. Ours is 2 samples. So you select 2 proportions. And it says data. What do you got for me? Both samples are in a column. Do we have data? No, we don't have the data. We actually have the summarized statistics. So you pull this menu down, and here we go. Summarized data. That's what we have. All right, sample number 1. I called number 1 those that attended preschool. So 62 were polled, and 38 of them said, yeah, I need social services later in life. So that would be 38 out of 62. And sample 2 was 49 out of 61. Go to the options menu, because this is where you'll select 1 tail, 2 tails for hypothesis testing and everything. So go to options here. Okay, difference, yeah, that's fine. The confidence interval, 95%. No, they want a 99%. And we are going to use the pooled estimate of the proportion. That's what this thing is doing here. It's a pooled estimate. And really there's not much to do here. Now this is going to also do the hypothesis test, but we should get the confidence interval out of this as well. So let it do its thing here. Alrighty, and here you go. So this is the confidence interval, the 99% confidence interval. So 0.3967, 0.0159, this is like 0.016 approximately. Now you can see this is 0.0163. This is off a tiny bit, as you can see. This is 0.3967, 0.3971. If you're wondering, how come these are off just ever so slightly? Well, that's because when I calculated this pooled standard deviation right here, I didn't keep all the decimals. I truncated this a little bit. And then also the z-score, 2.58 that we used in this calculation, the critical z, that 2.58 is rounded as well. So, if you keep these values to a couple more decimal places, then obviously you'll get a little bit nicer of an answer and you'll get it to match. This answer down here is a little bit estimated compared to this one right here. But this answer right here is fine, and so is this one. Alright, so that same procedure can be done in the calculator as well. So if you go to this calculator and hit the Stat menu and move over to Tests and find the 2-sample proportion confidence interval. So here's the hypothesis tests, 1 and 2 sample. The confidence intervals start at number 7. We just got to locate the 2-sample proportion confidence interval. Here's the 2 proportion z-test. We don't need that one. We need the confidence. The calculator separates the confidence intervals and the hypothesis test. 2-sample z-interval. No, we don't need that one. 2-sample t-interval. 1 prop. Here we go. 2 prop z interval. 2 proportions. Alrighty, so let's select that. Alrighty, same menu that Minitab had virtually. So x1 was the 38. N1 was 62. X2 is 49. And N2 is 61. This is a 99% confidence interval. So you go on top of calculate and let it do its thing. Error domain. Oops, let me see what I did there. Hold on. Finally, there it is again. Let's see what I must have entered something incorrectly. I don't know what the heck happened there. X1 is 38. N1 is 62. I think I'm just pushing the buttons a little too quickly. That's what the problem is. This calculator is slow when I got all this stuff running. Alright, so 38, 62, X2 is 49, and N2 is 61. Alright, so there it all is. Hopefully that looks good now. So it looks good there, and hit enter and let it do its thing. Alrighty, so let's see what we got. Negative 3967. 3967, as you can see, the calculator's output is matching Minitab's output exactly. Still off from our hand method, and the reason why it's off from our hand method is because of the truncation, obviously. This is there's some rounding going on here, but these are fine. 0.01597, 0.15967, okay, here we go. 0163, as you can see, does a pretty good job there. So the calculator and the Minitab software obviously are a little bit nicer on those estimations. Now, as far as interpreting it, you have to know what this is saying. So after you crunch this confidence interval, and here you have it, this is basically it's this last step on how do you read this thing right here. Well, it says the difference between the population proportions is somewhere between these two numbers. Now this number down here is about negative 39.7%. This percentage right here is about 1.6%. Notice that the difference between these two proportions, the number that is contained inside of here is the number 0. And that's key, because you're 99% confident that the difference between these two proportions is somewhere between these two numbers. So the question wants to know, is there a difference between these two groups? And since it contains the number 0, we would say no, it's not really that much different. If the number 0 is contained within the limits of the confidence interval, then you would say probably there's not much of a difference at all. If we were performing a hypothesis test, this would fail to reject the null hypothesis. Alrighty, so if you have any questions on this, shoot me an email. Like I said, all these hypothesis tests and confidence intervals, they're all in the software as well as the calculator.